Okay, so now we have a capacitor hooked up across the output of the transformer. It's a 16 volt, you can't really see it, it's a 16 volt 47 UF polar transistor, and by polar I mean you have to hook up the negative to the negative and the positive to the positive. Well, anyway, we have a little bit of a charge. This is left over from the last run. It's 293. I wanted to show you what the output is. Let me ground this out first. If we just touch these, you watch the voltage drop to 0. And I disconnect, and it climbs back up. It has, if you watch any of my other YouTube videos, it has the same characteristic of my water fuel cell. It comes up to a baseline voltage that it just makes constantly. That's because a polar capacitor is really another name for a battery. That's just a small battery, really. But anyway, watch what happens when I hook up now to our transistor. I believe this is the Myers effect, where step charging a capacitor with unilateral spikes of magnetic energy that's translated in the coils to pure voltage. Pure voltage goes to the capacitor, and slowly, because of the diodes, it can't. We don't have the best connection. It can't go anywhere else but charge the capacitor up. So this potential starts to store on the plates. Starts to store, and this actually has an electrolyte in it. It's basically an analog of my water fuel cell. And what it will do is, now if we could power a load, I'm going to get some LEDs, I'm going to hook up a load to it too. I'm going to show you that the capacitor actually makes the amps, makes the electrons. I'll actually splice into this wire, show you that no amp flow, and then I'll hook up and we'll see if we can get a reading. But yep, that's it for now. I just want to show you the step charging. We're up to 1190, yeah, and it will climb all the way up to about 21 volts. That's over the voltage for this capacitor, but it's cool to the touch, doesn't seem to mind at all, but that's basically when it fills up too. But yep, that's it.